Hey ChemStars, let's work through some of these practice problems for average atomic mass. Please take out your calculator. I want you to actually pause the video, and when I put some math problems on the screen, I want you to plug it into your calculator and double check that you're getting the same thing. We're going to start on page 10 with the example problems where I stopped in the last video, and I'm going to try and color code this, that way you can follow along and track my math going all the way through. So let's start with neon. So the first isotope of neon, which is the most common, 90.5% of neon, is neon 20. The second isotope of neon is neon 21. That's 0.3% of all neon. And then the third type of neon we have listed here is neon 22, and that's 9.2%. So before we get started, let's just make some quick checks. So the lightest neon is neon 20, neon 21, and the heaviest neon is 22. So then taking an average, that means my answer has to be between 20 and 22, and it should be closest to the one with the greatest percent abundance, which 90%, neon 20. So my final answer, if it's not between 20 and 22 and closer to 20, it means something went wrong. So to solve for the average atomic mass, remember that we have to go through and convert all of these percentages to decimals. Either type it in, divide by 100 on your calculator, or you can go through and move your decimal places to the left. So let's convert all those percentages first. So 90.5%, decimal equivalent is 0.905. For 0.3, that's going to be 0.003. And for 9.2, it's going to be 0.092. So now we can go ahead and start using that equation. Okay, so we're going to take the percent abundance, so the percent abundance is 0.905 times the mass, which is 20. Plug that into your calculator, 0.905 times 20. Actually pause it, plug it in, and come back. Okay, you should have gotten 18.1. We're going to do that same thing for the next isotope. So we have 0.003 using the decimal equivalent times the mass, which is 21. Plug that into your calculator, and you should get 0.063. Now let's take that last isotope. So neon 22 is 0.092 times 22. And that term from your calculator should be 2.024. Now to get my final answer, I have to add all these up. So take 18.1 plus 0.063 plus 2.024. Pause, plug it into your calculator. You should get 20.187. Now let's do our quick check. Is 20.187 between 20 and 22? Yes, that's good. Is it closest to 20 than any other number? Yes, that means everything's good. But wait, I have to include my units. So remember that new unit we have, it's called AMU, atomic mass units. Basically means how many protons and neutrons there are. Okay, now we've got that example. Let's try the next one. Let's see if I can move this all up a little tiny bit. I ran out of room on my next example. Okay, so the exact same way we're going to tackle the next problem. So we're looking at silver. Ag is silver. One isotope is 51.8% of all silver. That's silver 107. So my answer has to be between 107. And then my next isotope of silver is silver 109. Now that's 48.2%. Looking at those percents are pretty close. So technically I'm going to be a little bit closer to silver 107, but it should be kind of right in between them. So I'm thinking my final answer is maybe a little less than 108. So let's go through each term on that. Okay, so decimal equivalent. 51.8, move the decimal twice or divide by 100. 0.518. So I'm going to take 0.518 times 107. Pause, calculate that, and come back, please. You should have gotten 55.426. Now I've got to do the weighted average for the next isotope. So 48.2, make that a decimal equivalent, that's 0.482. So 0.482 times 109. Calculate that, pause and come back, please. You should get 52.538. Now we're going to add these together, and I get 107.964. Let's do our check. Is that between 107 and 109? Yes. Is it closer to 107? I mean, it's close to 108, but technically it's closer to 107 than it is 109. And that makes sense because look at how close those are. So it's about 108. So that checks out. Last thing I need is my units. And here is my final answer. I'm going to do one more practice problem with you in depth, and then I'm going to have you pause. I'll put down your final answers. You can come back and check those. So now, this one's tricky. Look, we've got 4 different isotopes. This is going to be a lot to try and squeeze in on this page. So we have lead-206, we have lead-207, we have lead-208, and we also have lead-204. So the highest number we saw there was 208. It's going to be the upper limit. And the smallest number we saw there was 204. That's going to be my lower limit. Now, when we have 4 different isotopes, it's going to be a little bit trickier to see. So the highest percent is lead-208, but then about almost 44% of that lead is down by 206 or 207. So my answer should be close to 208, right? But then we have quite a bit of the percentages kind of pulling it down to 206 and 207. So we'll figure that when we get there. Definitely shouldn't be near 204 though, so it should be up closer to 208. So let's see, what are all the terms of that one going to be? So I'm going to have to write that long ways probably. So we have 0.241 times 206 plus 0.221 times 207 plus 0.524 times 208 plus 0.014 times 204. Now, I'm not going to take the time to give you each term, but here's the final answer you should get. You should get 207.241 AMU. Now, let's do a check. Between 208 and 204? Yes, that's good. Is it closest to 208? Looks like it's closest to 207, right? But remember, we have that kind of big 206 number pulling it down, and we've got a 204 number pulling it down. So I'm going to say 207. Yeah, we're closer to 208 than we are to 204, so that checks out. Okay, so for these next problems, I want you to pause, set these up on your own, and I'm going to give you the final answer when you come back. Okay, let's go through and check your work now. So let's look at number 1 here. 39, 40, 41. That means my final answer has to be between 39 and 41, which it is, and it should be closest to the highest percentage, which is 39 at 93%. That's true. Here's your final double check. Go to the periodic table and see if you're close. So we're looking at potassium. Go to the periodic table. Oops. And let's see, potassium. Got to scroll up a little bit if I can. Potassium's number is 39.08. So is that close to what I was going for? 39.08? Yeah, that's close. That means number 1 is all good. Number 2, same double check. Okay, boron 10, boron 11. Final answer has to be between 10 and 11. Yes. Should be close to the higher percent. Okay, 80% is 11, so it should be closer to 11. Yes. And my last check now is to look at the periodic table and find boron. And the average mass of boron is 10.811. So let's see, is that third and final check, 10.811? Yeah, I'm really close. Number 2 is all good. So I'm not going to go through all 3 checks on the next ones. That's what you should be doing though. For the sake of time, let's just go through and look at our final answers. Number 3, iodine, should be 126.86. Number 4, iron, 55.85. Number 5, hydrogen, 1.002. And number 6, nitrogen, 14.0037. Some of you might be saying, what about sig figs? You haven't run it for sig figs at all, have you? Don't worry about that right now. So sig figs has to do with the uncertainty in the problem. I'm giving you all these things. These came from some measurements, but just don't worry about sig figs for this point in time. All right, thanks, ChemStars. Goodbye and good luck.